Welcome everybody to the second webinar that CIM Vancouver has held during these COVID distancing times. While it would be lovely to see everyone in person, at least we're able to at least get information and out to you. So welcome. So we thought we'd start this one off with a bit of a safety share. With everyone being away from transit and commuting back and forth, we're finding that wildlife is getting out more and more. This is actually a photograph that was taken in my driveway through our security system 2 Sundays ago. And you'll see here this lovely visitor that we had. And the interesting thing is I don't have the subsequent photograph, but if you look at the time in this photo, it was at 3:16 on Sunday afternoon. My husband and I had been out for a nice Sunday motorbike ride out to Fort Langley, had lunch, and we drove up our driveway at 3:18. The interesting event would have been if we drove up 2 minutes earlier. We actually drive up this side of the driveway and then in here to go under our carport to park our bikes. So it might have been a very big surprise for my husband, who normally rides up first, and the bear, and then subsequently me. So the safety share out of this is just be cognizant of, as we are getting out and about and moving more as life returns to somewhat normal and summer starts, that the wildlife has had their reign for a while, so you might come in contact. So make sure you go out prepared, keep vigilant, and just keep safe as you're camping, trekking, hiking, cycling, motorbike riding, or whatever that may be. So a couple of updates before we head into today's talk. This one here, it's June. We normally think of renewing our memberships in the end of the year. And so just now might be an actual good time to go and check your membership of the CIM National Branch to help support them. They're not for profit, and so we're trying to get more membership in. And at the same time, if you're able to go in and also renew your Vancouver membership, now would be a great time to do that as well. Moving along. Okay. One of the great things you'll get out of the CIM Vancouver and CIM National Branch are webinars like this. One of the ones for the CIM National Branch that is currently going on, you'll see from the date of the first session, if you didn't sign up for it, you've missed the first one. However, there are 2 new sessions coming up. Shaping Mining Development Projects is being hosted by Andrew Watson from Stantec, and there's a panel that'll be discussing that. And that's on June 23rd. And then on June 30, there's a business model innovation session that's also a panel discussion, and it is being hosted by Sarah Cavan, a natural resources strategy and sustainability consultant. So there's some great upcoming events that we should keep an eye out for. The other thing that the National Branch does is they've got a mentorship program, and what they're looking for is resources like yourselves on this call to partner up with students that are studying mining, geology, and a range of other mining related degrees. And it'd be a great way to impart your knowledge onto others and to help them shape their careers as they head forward. So if you've got an interest in this, please reach out to myself, Mary Jane Piggott. I'm co-chair of the Vancouver branch, or Yvonne DeBur, she's also co-chair of the Vancouver branch. Or you can just go on to the CIM national page and register for this event. For LinkedIn, if you are not in the LinkedIn group for CIM Vancouver, please go and check us out. And then we're a group that we require admission to, but yeah, come and join us. And while we can't actually connect at these sessions in person, the LinkedIn account is a way for us to maintain contact and greet old friends and meet new ones. So please come and join us. That's pretty much it for the updates for this one. I'd just like to thank Bedrock Services as our gold level sponsor. AMC Consultants also as a gold level sponsor. And then we've got a couple of silver level sponsors. That's Merit Consultants International, Pan American Silver, and SLR. So with that said, I'd just like to briefly introduce today's speaker. It's Peter Holbek. He's the VP of Exploration at Copper Mountain. I've got a blurb here on him, so I'm going to read from that so I don't mess it up. So Peter has held this role since 2007, and he has guided the exploration and resource development of Copper Mountain through early exploration, production financing, and mine development. He is also responsible for project generation and the identification and evaluation of growth acquisitions, such as Altona, which they purchased in 2017. Peter has an MSc in Geology from UBC. He has 40 years experience working from a range of companies from GSC, Tech, Kerr Addison Mines, Esso Minerals, and a range of others, and many juniors. And he's worked on a variety of deposits in a dozen countries on 5 continents. Sounds very impressive, Peter. He laments his discovery successes weren't economic, and his economic successes weren't discoveries. But he is happy that his career took place primarily in the glory days of exploration. So with that, Peter, I will hand over to you. I will stop sharing my screen and I will put myself on mute, and we are all ears for Copper Mountain.
Thank you. Thank you for that introduction. And I guess I should just, you've heard, I'm going to preface this by saying that I am an explorationist, but as this is a CIM, I'm going to try to cover almost all of the bases. And so just to give you an idea of where we're going, this is my table of contents here. So just a brief company overview. We'll talk a little bit about location. Mine history for this deposit is fairly important, so we'll cover that. A little bit of geology on the regional setting, discuss the deposit type, the geological setting so you can understand what's going on, look a little bit at the alteration mineralization, and then get into the mining, processing, and reclamation. So Copper Mountain is more than a single asset company. A few years ago, we purchased the Altona project, which is a ready-to-go IOCG copper gold deposit in Queensland, Australia, and we're essentially waiting on better copper prices before we launch that project. Copper Mountain is located just south of Princeton, British Columbia, which is 300 kilometers east of Vancouver. It's very accessible. We have a town nearby, so there's no camp situation. It is a little bit different than working in remote mine site locations for sure. The history goes back a long time. Deposit was essentially, or the deposit wasn't discovered, but the prospecting, first claims were staked in the 1890s. Initial attempts at production were in 1905, and that was BC Copper Corp, which was floated on the New York Stock Exchange. They had a little bit of difficulty and some low copper prices. They were reorganized in 1914 as Canada Copper Corp, refinanced, and they actually started underground development. They built a small mill, and they got the Kettle Valley Railway to start construction of a spur line. But before they achieved commercial production, they went broke. And then in 1922, Granby Mining Corp, Mining and Smelting Corp, bought the property, and they got the railway completed, and they developed an underground mine. That mine was started at 2,000 tons per day and eventually expanded to 5,000 tons per day. And initially it was long hole stoping and shrinkage stoping, but towards the later part of the mine life, they realized that if they went up and blasted material in the upper part of the stopes, they could, in essence, create a block cave operation, which is what they did. Total extraction was 31 million tons, of which 90% of that was from underground. And so what we're left with is this area that's outlined in green here, the solid shape, is a combination of the shrinkage stopes, the blast hole stopes, the caved zones, and then there has been subsidence in the years after they closed the mine in 1957. And so those are essentially now areas of broken rock. They were initially hollow up at the top, but these pit outlines were from 1996. And this is what the shape looks like, and you can see the underground workings here. And on the left here is a picture of the development, and this is their, they had an adit into the mountain here that was, went in a couple of kilometers to the underneath the deposit. They pulled everything out, they crushed it here, and then they loaded it on rail cars and transported it 3 kilometers to the mill site, which was a little more proximal to the town of Princeton and more accessible. Granby also had to start a coal mine, and they used the coal to generate electrical power, which they used to power this mine. They also had to have their own farm to provide food for the miners, and so the entire operation with coal power plant, Copper Mountain, underground surface facilities, and the farm was probably in the order of about 2,000 people on the payroll for that period of time. If we have a look at an air photo here, this is a 1996 air photo and shows the lay of the land here. The highway number 3 runs along on the west side of the property over here. Interestingly enough, the old highway goes through here, and this is the Ingerbell pit, which Newmont developed, and we'll get to that in a minute. In fact, I'll just go to that. The Newmont Mill was built here from 1972 to 1996. The original Granby Mill is up to the north, a couple of kilometers north of this photograph. And then the new mill that was constructed in 2011 was situated right here. So the way the history of excavation works is that Granby operated from 1927 to 57, 31 million tons of just over 1% copper. There is also silver and gold there, but we don't have the statistics on what they produced. Newmont came in, and actually Granby was still on this side of the property, but they didn't own these claims over here. Newmont actually acquired those claims and made a discovery, which was the Ingerbell deposit. They drilled that off, put it into production in early 1972, mined through here until 1980. And their production was 58 million tons of 0.42 copper and approximately a quarter gram of gold. But again, we just have total gold produced. In 1980, when they thought this deposit was exhausted, they built a conveyor system across the river and up to this point here, installed a new crusher, and started mining in what was termed Pit 2 and also in Pit 3. In 1988, they sold the operation to a company that was headed up by Jim O'Rourke, which was going to become Princeton Mining Corp, and Princeton took over operation in 1988. They mined in a number of areas, the Pit 3 area here. They also mined Pit 1, and they had a small deposit here called the Virginia Zone, and price of copper was dropping. They came over here and scavenged some high grade out of the Ingerbell pit, and then processed 10 million ton Ingerbell stockpile. And in the end of '96, the mine closed down and stayed closed until 2011, when operations were resumed with Copper Mountain Mining Corp, and Jim O'Rourke was at the helm of that company as well. And in the period between 2011 and 2020, which is now processed 110 million tons with an average grade of 0.34 copper, they have essentially merged pits 1, 2, and 3 in this area here. They expanded the Virginia pit, and they also mined a small deposit down here called the Oriole pit. Future production is going to come from these 3 areas, which is continued expansion of what is now called the main pit. Eventually, there'll be production in this area here, which is the north pit, previously referred to as the Alabama deposit. And then a large proportion of the future resources are going to come from Ingerbell, which we'll look at a little bit later in the presentation. And currently, reserves are sufficient for another 30 years of mining using a 0.1% cutoff. reserves of 477 million tons at a 0.3% copper equivalent. And well, current prices are a little bit unusual, but typically gold and silver account for about 20% of revenues. In terms of the tectonic setting, alkalic deposits, as they are known, all occur within the Quesnel terrain here in British Columbia. And I'm going to highlight the three deposits here: Copper Mountain, Afton, and Mount Polley. Are all very similar in terms of age, mineralization, alteration, and geology. And as you go north, the deposits are a little bit different. There are some similarities, but there are some differences as well. And if you want to include the western as part of this belt, then you have to come up with some interesting tectonic gyrations, which are illustrated here, and I won't really get into that. This is the Lowell and Gilbert model for porphyry deposits, and the point that I want to make is that it does not apply to the alkaline deposits, at least to the ones we have in BC here. This is the Silica Alkalize diagram. This is drafted by Jim Lang in a paper he produced, and the point I want to make here is that although we call them alkalic deposits, the reality is that they're really silica depleted deposits in relation to the calc-alkaline deposits that sit over here. Jim has grouped them into silica saturated and silica undersaturated. So Galore Creek would be over in this area, but the three deposits in southern BC are essentially just silica saturated alkalic. So that is that there is, you're just at the cusp of where you might get some free silica in the rock, but we seldom see quartz at Copper Mountain. One thing I will point out is that these alkalic deposits actually have more in common with the IOCG deposits in some of the IOCG deposits in Australia and the IOCG deposits that are in the Andes in South America. And the real features of these deposits is essentially that they're copper gold, high iron systems, plus or minus silver. We don't see cobalt and uranium like you do in some of the other deposits over here. They're generally low sulfur systems, so your copper sulfides are generally much greater than pyrite. You get sodium, calcic, and potassium alteration, but you seldom, or you see very little in the way of phyllic or argillic alteration. And this alteration is not zoned in a concentric zonation like it is in the calc-alkaline deposits as well, as we shall see. So high chloride solutions and lots of CO2 are critical features. You get lots and lots of calcite. You get very little in the way of sulfates, which is important for ARD. And then finally, structural control on the mineralization is very significant. And those could be pre-existing and or structures developed during mineralization. And then this key feature, which is the lack of quartz, which may have some implications in terms of the shape and size of these deposits, which will be points I'll make later. And this photograph here is just a magnetite calcopyrite pyrite breccia that occurred in the Virginia pit. And we see this type of feature. We have some magnetite breccia pipes located in Ingerbelle in the pit 2 areas as well. Looking at the geology, the key features that I'll just point out here, and we'll start from oldest and go to youngest. I don't think you can see this legend. So the green rocks in here and the blue rocks over on this side, this is all part of the Nicola group. I believe that these rocks over here, the blue is it's essentially sedimentary rocks with some limestone in them. And the green rocks over here have a higher metamorphic facies than the rocks that host the mine over on this side. These are probably older, and they appear to be in contact with the mine site rocks along fairly significant thrust fault shown here. This was essentially, essentially the core of a fairly large probably stratovolcano. So you have a pile of mafic volcanics sitting in here, and then you had the Copper Mountain stock and the Boit stock that have intruded into those. Both of these are pre-mineral. The Copper Mountain stock is significant in that it is zoned from diorite on the outside through to monzonite and then into syenite. And syenite's a little bit misleading because this is really just an enormous mass of coarse-grained case spar in here. It is my belief that this differentiation is possible because the lack of silica and the high alkalize mean that you had relatively low viscosity magmas. So that allows you to do to kind of do crystal settling in spades, which then allows this differentiation, which is actually driven by specific gravity change in the magma as you pull the mafics out. Orange unit here is the Lost Horse intrusive complex, and that is temporally and spatially associated with the mineralization. It is probably the mineralizer. And so we'll focus on that. This is the area that is mineralized in this area here. This purple unit over here is Cretaceous. It's the Verde Creek stock. And these, what we call the mine dikes here, which are quartz porphyry felsites, are the same age. So both of these units here are 100 million years, whereas everything else in this part is just sitting at the upper Triassic to lower Jurassic, so right on the Triassic-Jurassic boundary. And then finally, we have the Princeton group, which is a tertiary volcanic sedimentary succession that unconformably overlies everything in this area. The magnetics highlight the intrusives quite well, and I think this is where that fits, so you can see how it comprises the geology here. And I just will point out that although the deposits have some of the alteration is magnetite destructive, other parts of the alteration actually add magnetite. Magnetics is not really useful in terms of trying to find mineralization, because we have high-grade deposits in magnetic lows, and we have deposits sitting adjacent and within magnetic highs as well. Over here at Ingerbell, use of magnetics is great for understanding the geology, but not particularly useful for finding mineralization. The next slide I'm going to show is essentially a cross-section across here. It's just schematic, so you can see the relationships of the different rock units. And so this is what we're looking at. This pile of volcanics, which has some sedimentary units in it as well. These are actually fine-grained volcanic siltstones. In the field, they look a lot like cherts, but they are 49% silica, so they're just fine dust derived from the volcanics here, but deposited within a marine basin. The Copper Mountain stock sits over here, the Boit stock and the Verde stock over here, and then the Princeton group overlying everything. These yellow units represent the mine dikes related to the Verde stock. And then this is the Lost Horse intrusive complex. And if we just take a closer look at that in the mine area, this is really a mega breccia, large blocks of volcanic rocks. Some of them have been rotated, some of them are sitting still flatline, but they're essentially isolated from one another by the Lost Horse intrusion, which is polyphase, mostly syenite to monzonite, but it does have some pre-mineral diorite phases and some post-mineral syenite phases as well. But this makes it very difficult to actually derive a volcanic stratigraphy within the mine area. Everything's quite mixed up, and the degree of brecciation is quite variable depending on where you are in the deposit. Now, getting into alteration, this is really a high-level view of the alteration, the earliest alteration, and it's highlighted here in blue. Is essentially a core zone of intense Albedic metasomatism. Protoliths are generally indeterminate except on the margins, and essentially the rock has been reduced to an albite diopside mix, relatively fine-grained and textureless. And just here's an area where the Albedic alteration is attacking if I could use that word, a dark matrix. This is actually a hornfels, volcanic, or intrusive rock. And you can see the color differentiation here. And essentially this initially tacked along fractures, but then became completely, took over the entire rock here. In general, what happens in the albetic alteration, it drives all the iron out, all the magnesium out, all the calcic out. And then there is a kind of a late phase of mineralization, and so you get some disseminated mineralization in here, but typically grades are not as good as they are in the outlying or the outbound potassic zone. Potassic alteration, a little bit more widespread, and has a tighter correlation to mineralization. We also have a little zone of hornfels along the Copper Mountain Stock, sitting here and here. And that hornfels is just a fine-grained biotite, magnetite rich rock, but it also becomes a good host. All that iron becomes a good host to the mineralization. And this is a view of the potassic alteration that sits along this wall of pit 2. And it is a K-spar rich rock, and we thought that the orange color in here was just due to the K-spar, but this is actually a bit of a weathering phenomena because there is a fine hematite dusting that occurs within the K-spar alteration here that gives you this nice pink weathering color as well. Just to look at that in close-up, early albetic alteration, pervasive. It's really an albite metasomatism. Completely converts most of the rock. There's a few relic mafic phenocrysts that go to chlorite and then ultimately to epidote. And then this has been cut by K-spar veins and biotite on the selvages. And sometimes there's actually can be quite a bit of ornite and or calcocite that can sit in those selvages. And then a late calcite veining that is ubiquitous. And having a low sulfide system and lots of calcite, again, is a good from a reclamation point of view because most of the rocks in the area are not acid generating. Over at Ingerbelle, things are a little more intense and a little more complicated. And what we find here is the, in this case, the albetic alteration has this sort of late hematite staining. And here you can actually see there's actually a mixture of biotite and albite that makes this fine and very fine grained sulfides that make this dark colored. And it seems to have a closer relationship with calcite veining. Getting into the mineralization, this gives you an overview of, this is essentially a projection of the block model at 2% cutoff to surface. So you're just looking down on the blocks. So we'll get to a three-dimensional view shortly here, but it shows the main pit area, the pit 2, pit 1, pit 3 here, all together here. See a little bit of the previous pit outline right here. Virginia, Alabama zones, and then the Ingerbelle deposit over here. And I just highlighted that thrust fault, which actually cuts mineralization at about 45 degrees and is listric dipping out to the west here. With the Similkameen River here, and alteration is continuous across here. There's actually quite a bit of overburden in here, so at this point we don't know if this is mineralized, but we suspect it is. So you can see it's quite likely that a fair bit of mineralization has been removed by the Similkameen Valley. And if you do a volume calculation, it's probably in excess of 300 million tons of material is now somewhere down in the Similkameen Valley to the north and ultimately into the Columbia River. One of the things with the Ingerbelle deposit is that it does have some clear fault boundaries. We don't actually see that on the Copper Mountain side as clearly as we do at Ingerbelle. If we look at that in 3 dimensions, it just shows the block model here at a 0.2% cutoff. And you can see this northwest trend through here. These are just some IP chargeability lines that we that we show that just suggests that mineralization is continuing down here. There is a fault that cuts through this, so there may be some offset in a north-south direction between the Ingerbelle deposit and the Copper Mountain side. This block model represents, at this point in time, roughly 680 kilometers of drilling and some 350,000 exploration assays in the database. Length of this trend here is 3.6 kilometers. It's roughly 3 kilometers in this direction, and the vertical extent from the top of the deposit in the Oriole area, which is just off here, to the bottom of the drilling in Ingerbelle deposit is about 900 meters. This, I think, is an informative diagram. What this is copper grade, color-coded in blast holes. And what we've done here is taken 3 layers, and we took the existing pit bottom and took the benches coming up in topography, so 3 15-meter benches, and then draped them. So what you're looking at here is down at the bottom of the pit, and on the edges you're near the top of the pit. But what this shows clearly is the structural control on the high-grade mineralization. I've put in the felsite dikes here, and then some of the known faults. We haven't put them all in, but this is some of the faults, and these are faults that actually were not initially recognized in the geology, but were actually picked out by looking at blast hole penetration rates, and you can code those, and then when you look at them in 3D, the structures show up quite well. And some of these faults here are dipping at about 45 degrees to the northwest. And I'm just going to, the next slide will show some of the structural control that's on there. And what this might look like in hand sample, this is actually we have these features called, we term them pegmatite veins. And essentially they are sort of subpegmatite. This is very coarse grained biotite, a little bit of calcite, and then some case spar in here. And occasionally on a face in the pit, you will see these discs of calcopyrite. And this is a small one, but they can get up to 1 to 2 meters large. They're sort of very unusual looking. Puzzled over them for a while, but what they are is essentially deposition on at fracture intersections. And in this case, so you have one fracture that's sitting in this plane here, and then there's another fracture that comes up here, and there's probably movement on this face here. And so these are little disc-shaped zones of massive calcopyrite in there. And that is one of the features of Copper Mountain, is that in some ways this behaves a lot like a little more like a gold deposit than a copper porphyry, because you get very high concentrations of sulfide minerals in some areas, and then areas with no mineralization whatsoever, and sort of disseminated mineralization on the margins. That's a bit of an oversimplification, but that's kind of what we're faced with. And if I just add the interpreted structures here, those on there, and again, this is a fractal pattern here. What you see in outcrop, or what you see in a hand sample, you also see at the deposit scale as well. So again, emphasizing the fracture controlled nature of the mineralization in here. This, of course, creates some challenges for resource estimation. And before I get to that, just show again, I would say that just as a rough guess, probably 40 to 50% of our mineralization occurs as these coarse veins and infill of calcopyrite. And in this case, you can see there's really no, this is just infilled space. There's no selvages on these, and they're post alteration for the most part, so relatively late feature. So when you get that type of mineralization, resource estimation can be quite tricky. Overall, every year we, or sometimes more frequently, we do reconciliation to the actual mining, and so as the more we mine, the better we understand, and by the time we finish mining this deposit, we'll understand it completely. But it's a work in progress at this point in time. This just shows the resource estimate over here, and then this is reality as with the blast hole drilling. These are 15-meter blocks in the resource estimate and 7.5-meter blocks in the ore control model, or the dig plan here. And you can see, while the correlation is quite good, the actual numbers at the small scale can be a little bit different. And this one actually worked out quite well. The grades here were higher than predicted, and so the balance was quite good. This is an area here where a couple of erratic drill holes can, or not erratic, but a couple of high-grade intersections that lack significant continuity can result in a block of ore or a block of mineralization that's projected to be fairly good grade and tonnage. And then over here you can see that it doesn't show up. Again, little more high grade and at much higher grade sitting over here to help compensate for these losses over here. But it keeps you on your toes, and what we've found is that you have to drill in more than one direction. And in fact, in 3 directions is kind of useful, because our structures are dominantly vertical, but then multi-directional in the vertical sense. All of our exploration drilling is angled, and generally, like I say, we do it in 2 different directions, sometimes in 3. And you can use statistics to determine sort of what your favorite orientation of the ore-bearing structures are. This is, again, a revealing diagram here that tells us a little bit about the deposit. What we did to make this image is we eliminated all of the historical vertical drilling because it just provided too high of a density of data when you're projecting to a single plane. And this is just a plane view. All data has projected to a single plane. But what we did is we took all the angle drilling, we composited gold, silver, and copper on 15-meter composites, projected them to, and then we actually made the composites. We krieged them into 25-meter blocks and projected the data to a single plane, and then contoured it, or color contoured it here to get this map pattern of silver to copper. And this just shows the mine areas here. There's some drill data that extends beyond the mine areas as well. We also eliminated, we only looked at above 0 copper, or above actually 0.05% copper, just to eliminate the noise in some of the data. And this actually distribution is fairly revealing. This line between kind of the blue-green and the yellow is actually a fairly significant feature in the deposit, and really divides an area where calcopyrite is the dominant copper-bearing phase from where bornite and calcite are the dominant phase in the southern part of the deposit here. And I'll point out here that at around 0.3 copper, the silver grades in the Ingerbell deposit are 1/2 to 3/4 of a gram. In the Pit 2 area here, the silver grades are roughly 1 to 2 grams, and then in the yellow area down here, the silver grades are sort of 3 to 10 grams. And in this area down here, we get some drill hole intercepts where silver is measured in kilograms. So you can get some very high grade silver out on the edges of the deposits. If we turn to gold, we can see a very similar feature. And so Ingerbelle having the highest gold to copper ratio at an average of about 0.66 grams to 1% copper. And so here at 0.3, you're looking at almost 0.2 grams of gold, whereas over in this area, the gold at 0.3 copper is around 0.08 grams. And again, this is telling us a little bit something about the formation. Where you see these brown shades and up are the places on the deposit where you can actually find some pyrrhotite. It's not a lot, but it's an indication of temperature, and that's kind of supported by the presence of garnet that you see at Ingerbelle, which you don't see over at Copper Mountain. And it makes sense that this area to the north is hotter because this is where the Lost Taurus intrusions sit. And the Copper Mountain stock and the Void stock that are over here were pre-mineral, so this area was probably cooler. There's also some indication in the mineralogy that the precipitation of sulfide minerals here was probably due to standard cooling, whereas here redox and or mixing of hydrothermal fluids and connate water had more of a role to play, and that's why you get the different mineralogy in this section of the deposit. Geometallurgy is important, as the mill guys will tell you, and it was an underappreciated aspect when we first began, but we've been working towards getting that. This plan view here is essentially like the grade map. It's done with projecting 3 benches for the blast holes draped on topography. All of the blast holes are mapped geologically, but because you're mapping from chips and you're actually mapping fairly quickly, the legend is actually a mix of both alteration and sometimes lithology. But it's useful in determining, because both the alteration and the original lithology determine both what the rock hardness is, what the sulfide grain size might be, features that really affect the metallurgical performance of the rock is rock hardness, sulfide grain size, the amount of the pyrite to calcopyrite ratio. Those are the 3 features that really have the most impact on recovery. And I'll just point out I'll highlight some areas here. There's some zones in here and in this area here where we see higher pyrite ratios relative to calcopyrite. We've got a boundary on the alteration zone here, and those are those high pyrite areas, and these are very coincident with the 60 millirad chargeability, and if the 3D version of the Quantec Titan 24 survey is to believe at depth, these actually merge at depth and actually may reflect a late alteration or even intrusive phase during the mineralization. And then a couple of other sort of obvious boundaries. So this is an area where recoveries are lower, and these are essentially our different recovery domains here. Getting on to mining, it's a pretty standard drill blast shovel and truck operation. This shows we mine on a 15-meter bench, and the equipment, this isn't all the equipment, but essentially we operate with 4 shovels. There's 2 PC 8000 shovels, which was shown in the last picture. Those are both electric. And then we have a Hitachi 5500 diesel shovel and a small PC 4000 diesel shovel as well. 3 loaders, one of which is one of the largest loaders available here. Loaders generally do duty on the stockpile. There's 5 drills. And at the moment, this number may have changed actually, but in the order of 24 haul trucks. Mining rate is up to 200,000 tons per day. And you have to have some small equipment. Well, this is for stemming of blast holes. One of the aspects that was added early on to the mining, when you're mining with multiple equipment and multiple pits, it's useful to have a dispatch system, and adding that dispatch system has provided a measurable increase in mining efficiency. And that dispatch system is run in the control room. So here's all the haulage roads in the pit areas, and the trucks, and actually all the equipment has GPS on it. So we know where everything is at any given time. A couple of the other items that have proved useful is modular provision, which is on the shovels and the drills. They're not autonomous yet, but you sort of moving slowly in that direction. So the dig plans can be sent to the shovel electronically, and we know where the mineralization is coming from. And one of the features we're trialing at the moment is MineSense, which is an XRF unit. We measure copper; it sits in the bucket, and we get a grade in the shovel buckets, and that's appearing to be really quite interesting, particularly for the deposit type that we have here. In terms of pit development, a little bit challenging when you have a few generations of mining that are ahead of you. The pit 3 area here, this is where the underground mines took place, so there are underground development, and the collapse zones that sat in this area here, and a little bit in pit 1 here. Really, the mine procedure was essentially a series of staged pushbacks to these pits, which allowed you to balance the amount of ore and waste that was coming out at any given time. But the mine does employ a stockpiling strategy, and so we will low-grade material is stockpiled for processing at the end of mine life, and then we also run high-grade and mid-grade stockpiles that vary throughout the year. So if you're in an area where there's lots of mineralization and not so much waste, then you put that material on the stockpiles. And then when it goes in the other direction, then you pull from those stockpiles. Previous picture was from 1996. This is not quite from the same perspective, but close. This is from 2015. There had been one pushback all the way around in pit 3 here. And the first phase, the north side pushback on pit 2, and you can see the south side pushback is in progress, and then expanding the pit to the west here as well. And then the next photograph is from late 2018, and now you can see that pit 3 has merged with pit 2, and pit 1 has now merged also with pit 2 as well, and currently mining in this area, and will be for the next little while, and then eventually back to for another pushback in pit 3 that will actually go all the way around. North zone is sitting off to the left here, and then across the river to Ingerbell. So total mining approximated, including right back to 1927, is a total of 270 million tons with an overall average grade of 0.48% copper. And that came out of approximately 670 million tons, of which there's 60 million tons of that is the low-grade stockpile that's currently sitting off to the north of the mine site. If we get into processing, this is a view of the mill building, looking at the pit areas over here, waste storage areas here, and we'll just take a close-up look here to describe some of the features in there. Primary crusher sits over here, relatively close to the pits. Crushed ore is conveyed up to here. In 2014, a secondary crusher was added because the hardness was preventing full production getting through the SAG mill. And so this was added here, and the conveyor system is divided so that If this is out, we can still feed straight to the coarse ore stockpile. But when this is operating, which is almost all the time, this now becomes essentially almost a fine ore stockpile. As you can see here, the stockpile size is 200,000 tons, which essentially allows for 5 days of production. Although that has not been tested yet, but that's the design. And this is the pebble crusher that sits just outside the mill on a continuous circuit. And now we'll take a look at the inside of the mill. Pretty standard configuration. The SAG mill over here on the south end of the mill building. Ball mills number 1, number 2. One cyclone here, the other cyclone's there. The regrind mill is sitting here, and then on the other side is the flotation circuit. And there's really been I'm going to say a history of sort of continuous upgrades and debottlenecking of the mill to increase production. The aware system, what you see here is there's a closed circuit camera on the flotation tank with the light, of course, and this is monitoring the flotation bubbles. And this is the circuit. There's a few things here that, or here this shows 3 ball mills, and this is currently in progress. But I'll just highlight some of the features. And this is an area I spend much of my time in here, so excuse me if I might not get this quite right. So that's the disclaimer on this. But the biggest addition here was a secondary crusher. So the original mill was designed for 35,000 tons per day. With the addition of the secondary crusher, we moved to 40,000 tons per day, and we've been pushing that up. And we're actually probably in the, between 40 and 45,000 tons per day on any given day. When we get this completed here, this will allow us to increase grind and increase recoveries at an estimated throughput of 45,000 tons per day. The other aspect was the Woodgrove Aware expert system on the flotation. We also added a flash flotation cell, which increased gold recoveries and also pulled out some of the coarser Calcopyrite, which allowed you to work a little harder elsewhere in the flotation system. Improved the bubbles in the cleaner tanks with slam jet spargers. And then the 3rd ball mill, as I mentioned, will be coming in. And currently we're in the process of putting direct flotation reactors in here, which is essentially, if my understanding is correct, is flotation in basically in a vacuum, I think is what that is. But you'd have to ask someone else to clarify that. The control room in the mill, pretty much everything with the aware system can be seen from one operator, and so the addition of cameras and communications just allows better control on the whole process. And then finally, now I'm going to switch to the future of Copper Mountain. I actually, when I first started on this, I thought we'd be done with the exploration in a few years, but the more we do, we find the more we can do. So a few years ago, we went back and looked at the Ingerbelle deposit. We did a few years of drilling. There's quite a bit of historical data in here from Newmont. Much of Newmont's drilling in this area was vertical, and so vertical drilling and vertical structures isn't a good mix for doing resource estimation. So we came back in and drilled as best we could with angle drilling. Results were very, very encouraging. And so there's a new resource estimate and a new pit design on Ingerbelle here. And just point out that this is quite a bit of the drilling that's around the pit's projected to a single section, so the density is actually looks better than it is in reality. But all of these holes, with a couple of exceptions, ended in mineralization. So there's probably going to be another phase even further out in the future for this deposit. And this is just a view of the drill of the historical Ingerbell pit. It's got a pit lake in the bottom here. So that drilling together with the historical data gave us a measured and indicated resource of just under 200 million tons, 0.25% copper, with a fairly healthy gold grade here, contained 1.1 billion pounds of copper and 1 million ounces of gold. There's also a sizable inferred resource that requires additional drilling to upgrade the resources. And we had to demonstrate for both Ministry of Environment and interested stakeholders what this pit would look like and what its impact on the environment would be. So I'm actually just going to show this video, which I think is kind of interesting. So I'll just let this run here. So this is essentially, this is this existing historical pit with the Highway 3 over here. EnviroGreen Technology sits here, which is a waste treatment center. And this is what the pit will look like once it's been mined by the current phase that's being proposed. Similkameen River Valley down in here. Entire pit is roughly 600 million tons, or just under 550 million tons to get that 200 million tons of ore out of there. So you've got some waste material that needs to be dealt with. Next will go on 2 stockpiles, one to the north, which is going on top of existing stockpile. You can see the reclamation looks not too bad on this existing stockpile. Looks better right now when the grass is all green. This is the highway here. And then this is the southern stockpile sitting over here. This is where we, the plant where we treat the biosolids that we use for reclamation. And that reclamation is going to look like this when it's all said and done. And I'm not sure about the pilot here, but so the access from Copper Mountain to the Ingerbell will be via haul road. This was a phase 1 design that you can see over here. There'll be a bridge over the river. They put the river in flood here. Actually, it's never that full. So I think that's your 200-year flood level. But the access road has been redesigned to have just 2 switchbacks. And the reason for that is that will allow us to use trolley assist and therefore use BC Hydro as opposed to diesel fuel to carry that ore up this slope. The other feature that we're hopefully is that mining will open the pit up in this area, so this part of the road will not need construction, and then we can use the existing pit as a straight line ramp up to the crushing station. Oops. Just on the other aspect of exploration, If you're familiar with the New Afton, you know that that started as an open pit and then went underground with a block cave. Copper Mountain started with underground and block cave and then went to an open pit. But the future may in fact be back to underground. We have a high grade area in the core of pit 2 that sits at depth. It's similar to, although mineralogy is different, but it's similar to the high grade material that was mined underground in pit 3. The best drill intersection in there is 30 meters of 4% copper. And so this, I'll take a little bit of artistic license here and say that like New Afton, where their zone continued below the open pit, we see potential for, excuse me, for a parallel situation here, although this has not been drilled, so this is entirely speculative at this point in time. But there is a little bit of encouragement from the IP survey here. This is a 1,200 meter section. Although I would say that these 3D IP surveys below 600 meters, I take this with a grain of salt. And Ingerbelle is also an area that has potential for future underground block cave, because that actually very much resembles a pipe. And now just getting on to reclamation here. This is an area of the waste dump that has been resloped, and then we coat it with a mixture of GVRD biosolids and local wood waste. And this provides a very good medium for growing plants. And this was our first year. This is a nice kind of a type of ryegrass crop here. And if you drive by on the highway, you can see this green area on the waste dump. So it's looking pretty good. Biosolids is essentially the material, the solid material from waste treatment plant, from the sewage treatment plants in the GVRD. So if you live in the GVRD area, then I thank you very much, because you are contributing to our reclamation efforts every time you flush your toilet. So thank you very much. And now, just in terms of very high level conclusions here, in spite of all the drilling here, we still have lots of drilling to do. So I can say you can never drill enough holes. It's just, you can't drill enough. But I'll also point out that no amount of convoluted mathematics or geostatistics in technical term can replace geological understanding. And of course, when you have pit walls to look at the geology, it's certainly a lot easier than having to scheme it out just from drill core straight. So that's a huge advantage trying to do this in a mine situation as opposed to preliminary deposit. But I will say that sometimes if you could go back in time, you might do things differently. And so I think it's important that the deposit should dictate the mining method and equipment size rather than the other way around. A multidisciplinary approach to development, which really means not putting your professionals and consultants into silos, but really maintaining open communication, I think has been very, very beneficial for us. And so I recommend it for anybody. And of course, when you're dealing with low-grade deposits in a global sense, in order to stay competitive, you need continuous improvement in all aspects of the operation, particularly when you face metal price fluctuations such as we've just experienced. And I think I'll leave it there, and I'm going to hand it over to the moderator, and I'm not sure what their timing is for questions. So thank you very much.
Thank you very much, Peter. If you've got any questions, you will have seen that Shervin sent around a note to say you could enter it in there. Has anyone got any questions for Peter? Hi, Peter. How much of Ingerbelle resource is too close to the river to mine? That's from Chris Adams.
Okay, yeah, that's a good question. There is, let's just say the deposit is open under the river, and there is probably in the order of 10 million tons of pretty good grade material that that has to be excluded from the pit to have a sufficient wall between the pit and the river. The current pit actually goes, its almost total depth is actually 200 meters below river level.
Okay. Another one here from Mark Schultz. Have you mined through the entire historic underground operations, stopes, caves?
No, we have not. The stopes were, or the historical mine was on 8 levels. Those levels were 150 meters apart, or sorry, 150 feet, so 50 meters apart. And our mining has taken us down to between level 5 and 6. So we won't get to the bottom until the next pushback, which is at level 8.
There's another thank you here from David Turner, said it's a wonderful presentation. Here we go, one more question from Maureen Morrison. Is or was there any leach cap or supergene zone developed on these deposits?
Yeah, that's a really good question. And as it turns out, yes, there was when we mined through pit 2 on the south side, the Lost Horse Gulch used to go through there, which was actually a depression where the Smilkameen River actually flowed through at one time when the ice level was near the top of the hills. So there's a fair bit of erosion in there, and there was a small zone of supergene copper developed sort of in that valley bottom, and some of that occurred on the Virginia deposit, and some of it showed up on the south side of pit 2, but it was a relatively thin area of either you had not a lot of malachite, but you had neodicite, abundant neodicite, and also zones of native copper.
Another question here from Sandy McVeigh. Great presentation, thank you, Peter. Would you add to your lessons learned, don't backfill pits until condemned by drilling? I think the answer is probably yes, but.
Well, yeah, and there's a nuanced answer to that. So yes, it is. But on the other hand, we actually use pit backfilling as a staged process. One, to use it for ramps so that we can, extract more ore, but also because of the topography of the deposit area here and just the overall shape, it is sometimes more economical to backfill a pit and then move it again later than it is just to move it the first time. So it's not as simplistic, but in general, yes, I'd absolutely say that that the engineers always put the waste dumps too close, but it's a question of economics sometimes.
I'm going to skip one question because Sandy's got a follow-up, which is, have you done studies on in-pit crushing and conveying?
I believe that's actually in progress, and I could say that at the on the current economics, because of the upfront capital costs involved, and with the existing truck fleet, it tips the balance towards haulage at this point in time. But if continued exploration increases the volume of material, then as that volume of material goes up, then conveying and exactly in-pit crushing start to look a lot better. But I don't think we're there at this point in time.
A question from Peter Moore. Can you flip back to the aerial view and show with your cursor where the 800-meter haul truck trolley will be installed?
Okay, so let me see if I can do this. Yeah, I can. I'm just trying to get the right view here. Okay, so bridge out will come across over here. This will stay the same, but then there'll be one corner here, and then there'll just be a straight, there'll be a straight shot out to here and then back into the pit. So this gives you a, I think it's a 1,200 meter, maybe even, or 1,000 to 1,200 meter run here, and then another kilometer run up this way. which you can get trolley assist on. So there'll be 2 lines of trolley assist, and then maybe a 3rd one going up through pit 2 to get to the crusher. Hopefully that answered your question.
Another question from Maureen. How are your recoveries in the bornite ore?
The bornite ore, yeah, that's actually one area that we've done the, I guess, the least amount of metallurgical work on because it was mined early on, and then we're just sort of we're just about to start mining there again, so that work will tick up. But historical recoveries were reasonable, but we could certainly improve recovery. So we're getting 80, sort of low 80s in there, and if you increase the grind size, you can probably push that up to about 88. One of the issues there is you do get fine grained bornite intergrown with biotite, which is difficult for the flotation. So you need a fine grind to get high recoveries in there.
Question from Peter Stacey. Do you have slope stability problems when mining through the underground workings?
Not particularly, although we do slope monitoring. So we have sort of continuous laser surveys going. But if well, in the historical pit there, they actually had the pit slope went right through those stopes. And what happens is that over time, those pit walls unravel, so you don't hold the benches particularly well. But there's been no, the stopes, I guess, are small enough that there's not a large scale feature that looms as a threat.
Another question from Sandy. Trolley assisted is a great idea that's been around for a long time. Hope you do this here. Are your current trucks mechanical or electric drive?
The trucks are electric drive, and all the new trucks that replace the old ones will come with the essentially be equipped so that you can convert to trolley.
All right, I think that's all the questions for now. Thank you very much again, Peter, for presenting this to us. And I hope everyone has a lovely sunny rest of the Vancouver sunshine day. Apparently it's going to be short-lived, and we're going to be in for a rainy Father's Day weekend. Keep an eye out for upcoming Vancouver CIM events, and also check out the Vancouver National Branch, and as I noted before, see about renewing your membership. So that'd be great. All right. Thank you, everyone. Have a good day.
Thank you.